All right, welcome back, Mustangs. This is part two of Unit 2 Objective 2 notes. In this section, we're just going to be going through how to actually fill in these charts. So let's get started, okay? Everything kind of comes down to just looking at the parts that we see here and breaking it down into all the little things that we're asking. So we're going to be asking about what's the degree of this, if it's even or odd. Is the leading coefficient positive or negative, or what is the leading coefficient actually? The zeros of this, and what's the multiplicity of those zeros? If those zeros are crossing zeros or turning zeros, the end behavior, which is going to be that limit notation, and then what's the y-intercept of this function. All right, so let's get started on these. When we look at our first problem here, if I look at what this was multiplied out, at some point when I multiply this, this is going to give me an x cubed. And at some point when I multiply this, this will give me an x squared. So if I put those together, this is going to be a fifth degree polynomial. Okay, so my degree of this is 5, which is odd. Okay, the leading coefficient of this, if I took and multiply this whole thing out, at no point should I get any value bigger than 1. That's because if I have x minus 1 times x minus 1 times x plus 2 times x minus 1 again in here, and another x plus 2, what's going to end up happening is every single one of these x's, when they get multiplied together, doesn't have a value getting added onto it. So it's always going to end up just being an x to the 5th power when all is said and done and it gets multiplied up. So the leading coefficient for this is equal to a 1. How many zeros are there? Well, the zeros in this problem, the first one is right here. It's going to be when x is equal to 1. And the second zero in this problem is when x is going to equal to negative 2. Okay, let's go back and look at this one. The x minus 1 to the 3rd power, when we look at this, it's an odd power. That means it's going to be a crossing 0. So this will be a CZ. The other one in this, when we look at it, that x plus 2 squared, that's an even power. That means that this is going to be a turning 0. The end behavior for this, it's a 5th degree polynomial. The leading coefficient is 1. So what's going to end up happening is we're going to have a graph that's going to look something like maybe this. Doesn't matter what exactly perfectly it looks like. It's going to look something like this. So the behavior is, oh, I totally put these things in the wrong spot for this one. Crossing 0, turning 0. And it's a multiplicity of 3 and a multiplicity of 2 because that x minus 1 counts as 3. And then the x plus 2 counts twice. Going back to the end behavior though, we're going to say that the limit as my graph goes to the right, so as x goes to the right, the y value is going to go up to infinity. Okay. And then for my for the other behavior, the limit as x goes to negative infinity, so as my graph goes to the left, my y value is going to go down. Okay. I think the hardest part mathematically on this one is going to be what's the y-intercept. Now remember, the y-intercept happens on the graph when x is equal to 0. So if I take and I put in a 0 into this function right here, what do we end up with? Well, a 0 right here and a 0 right here would mean that we end up with a negative 1 to the 3rd power and then a 2 to the 2nd power. So this means we have a negative 1 times 4, which is just negative 4. So my y-intercept for this is going to be at 0, negative 4. That's it. All right, let's go and take a look at. Let's go and take a look at the next one here. We're going to go a little bit faster through this. Okay. This right here, we get that x is equal to 0. This we get x is equal to positive 4. Because I have x times x minus 4 times x minus 4. We have 3 x's in this problem, so this would be an x cubed at some point during the problem. So the degree of this is odd, and it is 3. The leading coefficient of this is going to be a 1. The zeros in this are going to be at 0 and 4. That 0 has an odd exponent, so it's only going to count once for the multiplicity. That x minus 4 has a 0 at 4, and it's going to count twice. So it's going to be a multiplicity of 2. Because it's a 1 for the multiplicity, this is going to be a crossing 0. And for that 2, it's going to be a turning 0. The behavior of this function, it's a third degree polynomial. It's not reflected. So the behavior for this is going to be that as limit as x approaches infinity, my y value is going to go up. And as my graph goes to the left, my graph is going to go down. If I take and I put in my x value is equal to 0, so we're going to, again, for the y-intercept, we're going to set x equal to 0. Come back over here and let's put this in. You can see quickly what's going to end up happening. If I put a 0 right in here, it doesn't matter what I do on this right side here. As long as I put a 0 in for that x, 0 times anything is always going to equal 0. So that means we're going to have a 0 at the origin there. And that should kind of make sense because that 0 that's right there is at the origin, which is 0, 0. All right, so the hard part here, doing this entire chart. Okay, let's see what happens as we work our way through this entire monstrosity, okay? It's like a little puzzle. Let's see if you guys can get this all. The first one, the degree is 1. So what this looks like is simply just y is equal to x. Okay? If the leading coefficient is positive, what we know is that my graph is going to look something like this. So the limit, as my x goes to the left, my graph is going to go down to infinity. As my graph goes to the right, my graph is going to go up. How many possible zeros can there be? Well, it's a first degree polynomial. There's a max of only 1. How many minimums or how many maximums are there? Remember that these right here are always going to be the degree minus 1. So it's always going to be whatever the degree is, minus 1. Well, if my degree is 1, and I take away 1, I'm going to have 0. That means I should have no mins and no maxes, which means there's a total of no extremas. Okay? Let's move on to the next one. If I had y is equal to x squared, what's that going to look like? If we have a positive leading coefficient, we know that the graph is going to look something like this. Okay, that's that standard U shape that we're used to. As my graph goes to the left, my graph goes up. As my graph goes to the right, my graph goes up. The maximum number of zeros in this, because the degree is 2, the maximum I can get is 2. How many maximums or minimums are in this graph? Well, there's a total of only 1 extrema, because remember that it's going to equal 1 less. And because it's that U shape, we know that that bottom point is going to be a minimum, and that there are no maximums. And 1 plus 0 ends up equaling the 1 that's right there. Okay? In this next one, they'd say, if you look at the information that's going on here, everything pretty much matches up. The 2 is the same, this is the same, this is the same. So it's like a little Sudoku puzzle. We're trying to piece all of this together. So if there's a maximum of 2 zeros, that tells me again that we're dealing with a y is equal to x squared situation. But what they're telling us is that this graph now is actually going to have a leading coefficient that's negative, so they're actually taking it and flipping it over. So that says that this graph is going to have this shape to it now instead. The degree of it is 2. As my graph goes left, it goes down. As my graph goes right, it goes up. There's 2 maximum zeros for this. Obviously, if the graph looks like this, there's going to be no minimum. There's going to be 1 maximum, and there's a total of, at most, only 1 extrema. All right, let's continue on. See, isn't this fun? The next one, we have a third degree polynomial. So we know what that generally looks like. Okay, that's usually the graph that's going to look something like this. If the leading coefficient is positive, we don't have that reflection going on. So let's break down each of the parts. As the graph goes to the right, it goes up. Graph goes left, it goes down. The maximum number of real zeros would be 3. The total extremas, if I have 3 for the degree, 1 less is going to equal 2. And if we look at the way the graph is structured here, you can see from that graph that there is 1 top and there's 1 bottom. So there's at most 1 max and 1 min. Okay. Next one, a 4th degree polynomial. Y is equal to x to the 4th. So the sign of the leading coefficient in this case, let's do a positive first, because if you look right there, they'll actually give you a negative for the next one. So if it's a positive, what would that graph look like? It's going to have this kind of a look. This kind of a look going on. Okay. So what they're showing in this is they say the graph, as my graph goes to the left, the y value is going to go up to infinity. So that tells you it's going to have that even function look, which, you know, both sides go up. So as my graph goes to the right, my graph is going to go up. The maximum number of real zeros is going to equal the power, which is 4. The maximum number of extremas, if I've got 4 for the power, it's going to be 1 less, which will be 3. And if we look at the shape of this curve here, you can see that there's going to be 2 minimums right here and 1 maximum in this picture. So 2 mins, 1 max. So there's 2 mins and 1 max, and that 2 plus 1 equals the 3 that we see there. That's a plus sign in the middle. It's kind of covered up with a line. Okay? All right, let's continue on with our little puzzle. I just destroyed that graph, so let me redraw that. It's going to look something like this. Okay. Let's move on to y to the, or y equals x to the 4th, but this time there's going to be that negative that's there for the leading coefficient. So the degree of this is 4. The graph is going to now actually look a little different. It's going to be turned over to look like this. So instead of it going up like this, it's going to go down. And so as my graph goes to the left, it's going to go to negative infinity. The graph goes to the right, it's going to go to negative infinity because it's going down on both sides. The maximum number of zeros for the... Oh no. I made a little mistake here. Sorry. I made a little mistake. Sorry, we have to erase. I totally ignored the fact that there was a 5 right there. So, pump the brakes. Let's go backwards here. All right, we got to delete this. Sorry. My bad. Should have looked at that first. All right, start that one over there. That 5 there is the maximum number of zeros. That tells us that we have a degree of 5. Okay, so I apologize. We had y is equal to x to the 4th, so now let's make this y is equal to x to the 5th. Okay, with the leading coefficient being negative, there's a reflection. So if it's an odd function, remember, we're going to look like this. Well, because of the negative, it's going to flip over. It's going to look like this. So what would that look like when I draw it out? It's going to be like this: 1, 2, 3, 4, 5. And what I just did was that as I was counting, I had it crossing the x-axis 5 separate times. Okay, so as my graph goes left, it goes up. My graph goes right, it goes down. Okay, 5 is the maximum zeros. That means there's only got to be 4 extremas. Look at our picture carefully. We can see that there's 1, 2, 3, 4 extremas, and you see 2 of those are maxes, 2 of those are mins. All right, so we get 2 and 2. All right, moving on to our next one. We've got 6 for the degree. So that tells me that it's going to be an even function, so it's going to look like this. But right away, there's a negative in this one, which means now the graph is going to look like this. So what's that going to look like? Well, 6 extremas. You ready? Or 6 zeros. There's 1, 2, 3, 4, 5, 6. 6 times across the x-axis there. Okay. As my graph goes left, it goes down. As my graph goes right, it goes down. There are a maximum of 6 zeros. If there's 6 zeros, there's a maximum of 5 extremas. And let's look at our picture. We can see that there's 1, 2, 3, and then 1, 2. Okay, so there's 3 maxes and 2 mins. 3 maximums and 2 mins. All right. 4 more rows and then we are done. All right, let's continue on with the information we know for this next one. So there's 3 minimums and 4 maximums. That means that there's going to be a total of 7 extremas. If there's 7 extremas, that means that there are possible 8 zeros. Remember, there's going to be 1 more 0 than there are extremas. So an 8 for the 0 tells me that my degree for this is equal to 8. That tells me it's an even function. If there's going to be, I want you to see what this graph looks like. There's going to have to be 3 minimums and 4 maximums. So what would this look like? So let's put the zeros in. We're going to have 1, 2, 3, 4, 5, 6, 7, 8. I don't know why that just got deleted. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. And what I want you to notice is it says that we're supposed to have 4 maxes and 3 mins. Well, if you look at the way I drew this, there are 4 mins, and there's only 3 maxes. So this tells us that the graph is actually drawn wrong, that I need to actually take this and flip it over to make this actually work. So let's do this again. Ready? 1, 2, 3, 4, 5, 6, 7, 8. And if we look again carefully at this, you'll see that there's 1, 2, 3, 4 maxes in this picture, 3 minimums, 4 maxes, 3 mins. That means that the graph is going down like this. So that tells us that the leading coefficient has to be a negative. Okay, so as my graph goes left, it goes down. As my graph goes right, it goes down. So that's all of that row there. All right. For the next one, rapid fire these bad boys. 5 and 5 gives me 10. The degree is going to have to be 11. That's going to be 1 more. They're telling you that as the graph goes to the right, it goes down. So if it's an odd function, that means it's going down like this. And sorry, there's an 11 there. That means the left side is going to have to go up like this. So that tells you it's been reflected over. So there's a negative here. And as my graph goes left, it's going to go up. All right, next one. Let me erase this so I've got some space to work with these. For our next one, we know that as the graph goes to the left, it's going up. That's from this. As my graph goes to the right, it's going down. That's from this. So this gives me a general idea that I know this is an odd function and that there's a reflection that took place. So there's going to be a negative in this front part. Now, they tell me that there are going to be 3 maximums in this. So let's draw what this would actually look like. You ready? There's 1 max, 2 maxes, 3 maxes, and then it goes down. Okay, so there's 3 maximums that take place here in this problem based off of what they said. Did I just do that right? Not 3 maximums. 3 minimums. Jeez Louise. It's getting late here. So there's 3 minimums, sorry. Okay. So let's look at the important information here. How many zeros are there? There's 1, 2, 3, 4, 5, 6, 7 zeros. So this tells us it's a 7th degree polynomial. Okay. The degree of this is going to be 7. The extremas is going to be 1 less, which is 6. And there should be 3 maxes. And if you looked at our picture, we have 3 maxes and 3 mins. All right, last one. And then we are done with this section. I know it's a beatdown. I said it. All right, so we've got a positive leading coefficient. The graph goes to the right as it goes up. Okay, so this infinity tells me that the end of my graph on the right side is going to go up. The problem says that there's a maximum of 4 minimums in this picture. So let's see what this looks like. You ready? Here's 1 minimum. Here's 2 minimums. Here's a 3rd minimum. Here's a 4th minimum. And if I continued on, what's going to end up happening is we would have another minimum, which we don't want. Okay? And this is important to understand here. The leading coefficient is positive. Now, technically, I'm going to tell you right now, there are 2 answers for this. I'll show you this one first, and I'll show you the next one. Okay? So if we use this information, we can fill everything out pretty quickly now. We know that there's a maximum of 4, 1, 2, 3, 4 minimums in this. And if we look, there's 3 maximums. So there's 7 extremas, which tells us that the degree of this is 8, which puts an 8 right here. And that says that as the graph goes left, then the graph is going to go up. Okay? Now I'm going to show you how there's technically a second answer for this because it doesn't actually give us everything that we need. Okay? Based off of the only 2 items being given to me, the fact that this goes to the up forever, and then it's got 4 minimums, watch this. Ready? I'm going to go 1 minimum, 2 minimums, 3, 4 minimums, And then I'm going to take it and actually continue off in this direction here. Now you notice based off of the parameters that it gave to me, I still have that this is in the correct direction because it's a positive. We've got that odd looking direction where it goes up and to the right and down to the left. I've got that the graph goes to the right, it goes up. And I've got, like it said, 4 minimums. There's 1, 2, 3, 4. So this generated 2 different things. So technically when we made this is actually a mistake, but that's okay. I'll show you both anyways, just so we don't run into problems. So when we look at their answer here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Leading coefficients positive. It goes to the right as it goes, I'm sorry, that one is as it goes to the left. So as it goes to the left, the graph goes down. As it goes to the right, it goes up. The degree of this is 9. There are a total of 4 maxes and 4 mins, and the maximum extremas is 1 less, which is 8. That is it. This is more just for fun and to give you a better understanding of like what the graphs look like. But I'm confident you guys have this. If you do have any further questions, please feel free to reach out. Otherwise, you guys take care. Don't forget to like and subscribe, and be safe, be respectful, be responsible. Have a good one.